let's do one more of these probability problems before we move on to talking about complements. In this problem, I'm looking for the probability that the second of two dice that I roll is greater than the first that I roll. And again, it doesn't specify what kind of die, so we can safely assume that this die has 6 sides, or is a d6. Later on, we'll talk about cases where that's not always the case. Now, we know that for 2 dice, the number of outcomes on the first is 6. It's independent on the second, so number of outcomes on the second is 6, leaving me a total of 36 total outcomes. So I know for this probability, the denominator is still going to be that 36 total outcomes. Now the question, how many different ways can I roll the dice so that the second number is higher? In this case, sometimes it helps to sketch a little bit and map out your possible outcomes. So for example, say my first number is a 1. How many different ways after that can I get a number that's higher? Well, pretty much everything except 1 would be, right? 2, 3, 4, 5, or 6. So that represents 5 ways there. Say my first number was 2. How many numbers could I roll on the second die that would qualify as higher? 3, 4, 5, and 6. So there's 4 ways. And then 3, if I see a pattern here, I should probably kick it in. If I roll a 3 on the first die, 4, 5, and 6 would be greater. If I roll 4 on it, 2 ways. If I roll a 5 on it, 1 way. We'll not circle that. That's 2 ways. Only a 6. If I roll a 6 on the first, I'm not going to roll higher on the second, so I don't need to count that. So my sample space for this, the number of outcomes I'm looking at, is going to include 5, 4, 3, 2, and 1. So 9, 12, 14, 15. There are 15 ways this can happen. And now I can go ahead and I can finish. So I'll go back into my calculator here. 15 divided by 36 gives me 0.42, or 42% of the time. And that's your basics for probability. Now let's talk complements. When I talk about the complement of an event, what I'm really defining is the probability that it does not happen. So for any event A, the complement of that event would be not A. If I were to say the probability of rolling a 6, the complement would be the probability of not rolling a 6. And here's the good news. It's not that hard to come up with. As a general rule, the probability of not having an event occur is 1 minus the probability of it occurring. Now, the advantage here is quite often when we think about problems that we want to look at, especially when we get into the compound side of things, it's often much easier to calculate the odds of something not happening than happening. And then you can simply transfer back and forth. So for example, let's say that we were to sign up to have, for our school spring picnic, a bungee jumping platform brought out. And we know that the probability of an accident is 2%. So the probability of there being an oops, 2%, 0.02. So that would raise the question, what's the probability that we would have a safe jump? Well, simply put, that's going to be 1 minus the probability of there being an oops. Because safe represents not oops. Do the subtraction, and I'm down to 0.98, 98%. The probability of an event happening and it not happening should add to 1, because either it did or it did not. There is no middle ground here. We're not doing fuzzy math. So for every event, there's a complement represented by the word not. And to calculate that probability occurring, we simply subtract the probability of the event we wanted from 1, and that will give us the probability of it not happening. Another example. In a standard 52 deck of cards, there are equal portions of the 4 suits. So if I were to take a standard 52 deck of cards and talk about the probability that I'm going to draw out a heart, simple enough. They represent 1/4 of the deck, 13 out of the 52 standard cards. Now, for the one of you that was just thinking, he forgot the Joker. Yes, we leave the Joker out because if we were to include the Jokers in our standard deck of 52 cards, the deck would now be 54. If it says deck of cards, you may assume there are no Jokers involved, including the one sitting there at home thinking he forgot to mention the Jokers. Now, this equates down to 1 out of 4, 25%, 0.25. That one we probably remember from the last time we studied probability. So, what's the probability if I'm going to draw a card at random out of my deck? It's not a heart. I could count up all the different ways a heart could not happen. I could count up the clubs, the spades, the diamonds, and go from there. Or 1 minus 0.25 and I'm done. Simply take 1, subtract the probability of the event happening, and you have the probability of it not happening.